Okay, so we're here with our AP statistics students going over real AP questions from, I think, 2012, 13, 14, 16 maybe, something like that. So recent years, all right? And if you're interested in learning about inference with means, this is the video to watch. All right, so number 10. When I read this question, the moment I read this, I thought, okay, 99% of the students will get it wrong. All right, and here's why. They're asking you for a confidence interval, and when you look at the answer choices, you should see they all have the same test statistic. I shouldn't say test, I should just say statistic. This is from the data. All right, this is the average hours worked per week. Yes, by college students. All right. And then, so that doesn't help us eliminate anything. That's all the same number. And you'll notice these numbers are different. So it's going to come down to the second number. What would you call that column? What is that column after the plus or minus in a confidence interval? These are margins of error. Margin of errors? I don't know. Margins of error. Okay? That's what we're looking at. Does anybody remember the formula of how to calculate margin of error? T star times standard error of your statistic. Now you'll notice they already gave you one of these. No, they did not give you T star. That does not say T star, it says T stat. That means it's a test statistic. So actually, I was telling Nadia's group, this is just what they would call confounding info. They're giving you more information to mislead you. All right? And you know, as a taker of many tests in your life, it happens. All right? So they gave you standard error, 0.707. So now it comes down to, can you find T star with 25 degrees of freedom? And we can. Let's draw a little baby curve. Nope, not baby shark, baby curve. Although we did just purchase a toy at Target for Catherine because she loves that song, where it plays baby shark while, you know, like the little fishing things that have the magnets in them and you try to hook them. Yeah, so she does that, but she doesn't know how to do that yet, so all she does is just dance the whole time. And then Henry's like, "You're doing it wrong." I was like, "Henry, it's not about that, it's about her having fun." Anyway, that's my life. 95% confidence level. Is that right? Yes. So then I was asking one of the groups, what area is on either side? Actually, not the p-value. That's what they still want you to get confused, Tanya V. Not the p-value. This is just confidence level. So it's 2.5% on either side. Like you'll notice, I crossed this out. Don't look at it. It's not helpful for this problem. All right? So you have the option of finding this T-star or this T-star. I think the easiest way to do is to find the negative one, the one on the left, by plugging in 0.025 to inverse T, which, if you checked your email yesterday, I showed you how to push the buttons to use inverse T, all right, in a shared document. And now you're going to get it real life here on the screen. You guys ready for inverse T? Yes, you ready for inverse T? All right, here comes inverse T. So you go to calculate. So just calculate. It is. Menu. The shared document. Sent you an email yesterday.
No, what's the...
Inverse T. Inverse T. Statistics. Distributions. Inverse T is number 6. The area I'm typing in is 0.025. For bonus points, Michael, what's another area I could type in? It's okay.
Isn't it 97?
It's 0.975. The positive one would be 97.5% to the left. Okay, when you drew that curve. So I don't think it's worth doing that. I just do the lower one. I think the degrees of freedom was 25. Yes, confirm? Yes, okay. So here is T star, 2.05954. So replace that in your formula. And if you multiply this number times, what was the standard error, 0.707? You'll get your answer. Obviously, I don't care about the negative. You'll see the answer is 1.456 for the margin of error, which gives you letter E. Questions? No questions? Everybody good?
Yes.
All right. The next one. Who's got another one?
39.
39. What year is that? 2014? Oh, about Frank? Whoa. It barely fits on the screen. Wow.
That's a sign.
It's a sign that this is a reading test, as I told you in the beginning of the year. Okay. I'm not sure everyone got to this question. Okay, we're gonna. So is it? Should I just summarize?
Yes, please.
Let me summarize. So you've got Frank and Lily, brother and sister, best of friends. They decided to live apart. And even though they miss each other terribly, they do correspond by mail. All right? And they, being statistics students, are curious to see if there's a difference in the average delivery time in days going in either direction, from Texas to Japan or Japan to Texas. All right? So, if you look at the table, you can see they used 12 letters from going from Japan to Texas, and 9 letters going from Texas to Japan. Here are your statistics. Here are your test statistics. And you'll notice, I think this question is talking about p-value. Yes. So really, I'm focusing on this number right here. Now, the moment I see that, what do I think about a p-value of 0.058? It's above, well, does it say what alpha we're using? It does?
Using a significant level of point.
It does. Good thing's not it. It's in the question. Classic. My bad, I missed it too. So the moment I read that, I saw that it's above alpha. And I think I heard Margot's group, and maybe it wasn't for this problem, but Margot's group was talking about the decision you make when your p-value is above or below alpha. Above is fail to reject the null. Below alpha is reject the null. So this is a fail to reject the null. And the null in this problem would be that there's no difference in the average delivery times going in either direction. All right? So we have no reason to believe that there is a difference here. So the one that makes sense, first off, I cross out A, B, and C because I see there is convincing evidence. That would mean your p-value is below alpha, but it's not. So that's why those are wrong. So it's D. What's that? And why do I not care about the sample sizes being small? I mean, it doesn't matter, but you would assume that if they run this test, that they make sure to check a condition, the nearly normal condition for each of these samples. So I'm assuming if they went through with the test, that they checked it and everything was fine. Their histograms were unimodal and roughly symmetric. Questions?
No, sir.
All right, that was a good one. Okay, what's next?
A good long one.
31.
31 going back. This one? Wait. Yes, 31 is here. It's tiny. Okay.
Yeah, this one.
This one? Okay. This one is a really good question after we already talked about inverse T. Inverse T is where you have the area under a curve and you're trying to find a T value, or T star in that case. In this problem, they give you the test statistic of 1.935. So they give you the T value and you want to find the area, P value is just area. Then you're using, instead of inverse T, you're using TCDF. So this is a problem of using TCDF. This is 31. So 31 is using TCDF in the calculator. All right. They're basically saying, here's our curve. What was the T test statistic?
1.935.
Thank you. And which direction are we shading? How do you know? How do you know it's greater than? Because the alternative hypothesis says greater than, so I'm shading to the right. So to find this, that area, that's called a p-value. And we're going to use the calculator. I would say that basically in the last couple of months until the very end, this new stuff is really challenging without a calculator. Okay? So make sure you're bringing that Inspire every day. So, menu, statistics, distributions again. Where is it? There it is, distributions. TCDF. And a few groups were having the discussion about between TPDF and TCDF. CDF is for shading. Anytime you shade, use CDF. TCDF. So that's number 5. The lower bound is our T value of 1 point. Give it to me again, Luis. 9. All right, 935. Upper bound is infinity. Right? It's really fun to say. No. And then degrees of freedom, it was a sample size of 7. So it's n minus 1, which is 6.
Wait, Mr. Grant.
Yes.
So would that not work if it was, that wouldn't work if it's a 2-paired, right? I mean, a paired, because you said you can't take the degrees of freedom like that, minus 1.
Yes, if it was a 2-sample, if they're doing a 2-sample t-test, then they would be giving you the degrees of freedom. Like the problem we did with the finding inverse t, right? It gave you degrees of freedom of 25, right? And like with the one you guys were doing about the teachers, right? The computer will give you degrees of freedom. Okay? All right, so what do we get? 0.0506. 0.0506 is D. Now, why do you think people put E?
I don't know.
This is the most common wrong answer.
I don't know. I didn't get it wrong.
What would a student do wrong to get E, which is the most common wrong answer? Do you remember where we shaded? So if you shade both, then you double the p-value. And if you double 0.0506, you get 0.1012. So just that's students not looking at the alternative hypotheses. That's just, they're looking at just doing two-tail. All right. So if this would have said not equal to, then it would be both tails. Yes, that link in your head? Yeah. Okay. All right. Let's do another one. 29. Going backwards or forwards? Forwards. Oh, we're on like the, wow.
Don't worry, we skip around.
We're going all the way to the last year.
The best year, you know.
Oh, the one with tomatoes. Good times. Tomatoes are what?
Are the worst fruit.
Why are they the worst fruit? Okay. 29. So since this group was bouncing around, I assume that not every group got to do this one. So to summarize again, just like our classic story of Frank and Lily, this other classic about the great tomato vine, they were looking at 2 different types of fertilizers in growing their tomatoes. They were seeing if there was a difference in the 2 of them. And it looks like, okay, it doesn't say anything about which one is like being more, it just says different, right? Yes, so that means we're going to be using what for our alternative? Not equal to, what number is this?
29.
29, okay. So 29. So we're going to use the null is that the average for the fertilizer A minus the average for fertilizer B is 0. Why am I assuming that? I'm assuming there's no difference between fertilizer A and fertilizer B. My alternative is that there is a difference. So it would be not equal to 0. Because if I check that problem again, I'm trying to think if it says, I don't see anything on here that tells me they think one will be more than the other. Okay? Is everybody good so far with the hypotheses? You don't have to do this. I just find students have more success if they write down the hypotheses if they were to have run the test. Obviously, you're not going to run the full test. You're going to have the button pushing in the calculator. All right, but I think it'll help to kind of frame, well, what am I trying to prove here? I'm trying to prove that there's a difference in fertilizers. All right, so let's go to real quick, decide what test we're going to run. We have two groups. So do you think that they are independent or are they not independent?
Not independent. Not independent.
So one thing I will tell you, and again, I don't want you to become like students, like when I say something, they're like, oh man, every time. It's not how this works. But one of the things, if you're struggling between if they're independent or not, is to look at the sample sizes. If they were related, they have to have the same sample size. And you'll notice one has 16, one has 17. Now, the fact that you're using different fertilizers, if they were related, it would have said, we're going to grow this plant using fertilizer A. Then we're going to wait 3 months and then grow it, or the next harvest, and grow it again with fertilizer B. Right? Using the same plant before and after, or like for the first time at the same time. It doesn't say they're doing that. In my mind, they've got two fields, or two areas of the field, and they have everything the same except for the fertilizer. Okay? All right, so let's go to the calculator. Menu. And Marcelo, this would be a chance to follow along from the document where it was a 2-sample t-test. 2-sample t-test. Yes, Marcelo, did you hear that? Great. You made it onto the video, dude. So statistics, stat tests, 2-sample t-test, which is number 4. Oops, I hit the wrong one. There we go. Now, do I have data? Like, did I put all of the individual 16 and 17 yield values from these tomato plants? No. They've given me statistics, so I put in the document, like, you need to decide if you're doing data or statistics. In this case, it's statistics or stats. Hit OK. I'm going to use A as 1. Is everybody good with that? A is 1? Yeah. Yes? So what was the average for the fertilizer A? 19.54. The standard deviation, 3.68. The 16 tomato plants,
23.39. 4.93.
okay, and then scroll down. Oh my goodness, what's the alternative? It's already there. And should you pool? No, because pooling is for what? Pooling is for proportions. Pooling is for fools. That's a good one, but no. Pooling is for proportions. PP, exactly. Alliteration. All right. Now, if I write down my p-value is 0.01614. Great. So this is what I'm going to use in my answer. P-value of 0.016. So let's go ahead and take a look at the answer choices. Now, it doesn't give alpha this time, right? Doesn't give alpha this time. But a p-value of, was it 0.016? To me, that's pretty significant. Right? I know it wouldn't reject if your alpha was 0.01. But it would reject the null if your alpha was 0.05, which is traditionally what we have used. So in my mind, you actually are all good because you just have to find which inequality it matches up to. So you don't have to worry about alpha. You got to figure out where does it lie. Is your p-value greater than 0.15? No, it's below 0.15. It's 0.016. It's not in between those two. It's not in between those two. The only ones that it's in between are 0.01 and 0.05. So that's letter D as in dog. Yes. Does everybody see why it's D? Yes, because it's in between that inequality. This one here? Yep. Okay, it looks like that's all the time we're going to have. So I'm going to sign off here. I apologize we didn't get to all of them. Watch this video if you want a refresher, but ultimately, you have the answers. So talk to each other, or you can even find me tomorrow during lunch if you'd like to go over some of them. All right? Find me if you can. All right? See ya. See ya.